Okay, let's start. So this is the last week of the semester, week 14. We will cover the last chapter, which is called Association Basics Concept. So this is one of the chapter that I skipped last semester or the previous semester. But I have included this one again because of the importance of this chapter to many people, especially in the business domain. Okay, so this is one of the method that they use to analyze the transaction. So this is called market basket analysis. So this is very useful in the business or the marketing domain. Okay. So just to give you the description of the method, which is called association rules mining. So given a set of transactions listed here, so we want to find rules that will predict the occurrence of an item based on the occurrence of other items in the transaction. So in other words, we want to find these rules. So for example, if we buy diaper, we also buy beer. So if we buy milk and bread, we also buy eggs and Coke. And if we buy beer and bread, we buy milk. So this is considered co-occurrence and not because of implication. Implication means that if I buy diaper, so this costs me to buy beer. But in fact, we are looking at the frequency of these two items that always come together. Yeah. So if you look at this transaction database, this is a sparse database in which each row will have different number of items. So over here we have 2, this is 4, 4, and so on. So different number of items per row. So what is the application of this association rules is that, for example, if we have these bagels and potato chips, so we are saying that the potato chips as the consequent can be used to determine what should be done to boost its sales. So we can see that to boost the sale of potato chips, these are the items that will be used in order to boost this sale. Bagels in the antecedent, which is on your left-hand side. So this is your left-hand side. This is your right-hand side. Can be used to see which product would be affected. So bagels would affect the potato chip sales. Okay, and this can be used to see which product would be affected if the store discontinues selling bagels. So if you discontinue selling bagels, the potato chip would be affected. Okay, so we are saying that bagels in the antecedent, which is on your left-hand side, and potato chips is in the consequent on your right-hand side, can be used to see what products should be sold with bagels to promote the sales of potato chips. Another application is that in the supermarket shelf management to identify items that are bought together. So buy sufficiently many customers. So this is based on the frequency. So the approach is to process the point of sale data collected with barcode scanner to find dependency among the item that we have in the store. So for example, a classic rule, if a customer buy diaper and milk, then he is likely to buy beer. So these are the rules that we can extract from the transaction database. Okay, so let's say don't be surprised if you find 6-pack of beer next to the diaper because of this finding. Okay, the 6-pack means the beer is in the 6-pack package. Okay, the strength and weaknesses of this is one of the method used. So we will study this method, a priori algorithm. So this a priori algorithm is used to generate this rule. So from this sparse database, we will have this rule. So the method we use to extract this rule is called a priori. So we will study this algorithm. So the strength is this is ideally suited for working with very large amount of transaction data in your database, written in rules that are easy to understand. So we can extract the rules easily, and useful for data mining and discovering unexpected knowledge in database. So this is sometimes useful when you want to understand why certain thing happen because of prior event that we have. Weaknesses, not very helpful for small data set. Okay, so we need a lot of sample because this a priori depends on the counting algorithm, depends on the frequency. And then take effort to separate the insight from the common sense. So we some of the rules that we have are common sense. So we need to look at what are the additional rules that can be taken as unique or insight, different from the common rules that we have. Okay. And next one is easy to draw spurious conclusion from random pattern. So this one is one of the weaknesses in applying a priori. But the basic idea is how do we find these rules given the sparse database for us to manage our store properly or to do some promotion in bundle. Okay, so let's take a look at the definition of frequent item set, because as I mentioned just now, a priori algorithm highly depends on the frequency. Okay, but we need to look at the definition of frequent item set. So given this is your sparse database, okay, so we define item set, a collection of one or more items. So we say that this is item set, a collection of one or more items. We also can have K item set, where K refer to the number of items that we have in our study. So, for example, if we say 2 item set, so which means that we have only, or we need to consider only 2 items in one set. Okay, so based on this definition item set, then we can define how to count them. So we have a support count is the frequency of occurrence of an item set. Okay, so for example, we look at, okay, this is 3 item set because we have 3 items in this set. So we want to find the support count. So basically we are counting from this 5 transaction, how many transaction that consists of these 3. So we have milk, bread, diaper, which is this one. So we have only two, 1 and 2. Okay, so this is the support count of the K item set. So in this example, we have 3 item set consisting of milk, bread, and diaper, and the support count is 2. Okay. But when we define support, so support is a fraction of transaction that contain an item set. So we have 2 just now, so we have 2 out of 5. So the support is defined as a fraction of transaction that contain that particular item set. So this is 2 over 5. Okay, so the support count is just counting. The support is the fraction of transaction that contain an item set. So based on your full data set. And also we have this frequent item set. We need to define what is frequent here. So this is the threshold. So normally we will set 2 or 3 or 5 depending on the characteristic of our data set. So an item set whose support is greater than or equal to the minimum support threshold. So this is set by the user. So for example, the minimum support is 3. So that means this is not a frequent item set. But if this is set to 2, so that means this is frequent item set. Okay, so this is will be set by the user or will be informed to the user of this system to know that what is the minimum support threshold. So when we look at the association rules, we have 2 parts, which is the left hand side and the right hand side. So your X is on your left hand side and this is your right hand side. So in other words, this is your consequent, this is your antecedent. Okay. So we also have this matrix to evaluate. So we have looked at the fraction just now, which is the support. So the support is basically the fraction of transaction that contain both X and Y. So if we take this one, so the support for this is 2 over 5. Okay, and the confidence measure how often item in Y appear in transaction that contain X. So when we look at this example here, so for the support, we just take 2 over 5 because this is number of transaction. So number of transaction 5, and this is the support count of this item set, which is 2. Okay, the confidence here, we look at the count of the item set here divided by the count for the antecedent. Okay, so this is X and Y, this is X. Okay, so it measures how often item in Y appear in transaction that contain X. So this is the confidence. Okay. So between these two, confidence will tell you more about how do we actually evaluate the rules. Okay, we have another one that will use the support matrix. So Leaf is a key metric in association rules that measure the strength of an association rules by comparing the observed support of the rule to the expected support if the antecedent and consequent were independent. So this is, we are looking at the support for A and B, the intersection of A and B divided by support A and support B. Okay, so the higher is the value, the better is your rules. So what is leaf? Leaf quantifies how much more likely the consequence of an association rule is to occur when the antecedent is present. So we are looking at the likelihood of the consequent to appear when you have the antecedent. Okay, compared to when it is absent. So this is the formula here. So basically we use the support. Okay, so we have support, confident, and also leaf. Okay, let's take a look at the association rules mining task. Okay, so given a set of transaction T, the goal of the association rules mining is to find all rules having the following condition. The support is greater than the minimum support, the confidence is greater than minimum confidence threshold. So these two are the value that we use to minimize the number of rules, because we are setting the condition for all the rules that having minimum support greater than having support minimum greater than the minimum support and confidence greater than minimum confidence. So this is just to reduce the number of rules, and we only highlight the high value for the support and confidence. Okay, so what we want to do is we want to list all the possible combination of the rules. So basically we start with one item, two item, and three item in order to look at which one is the frequent item set that we have. Then from there we can generate the rules. Okay, so for this we will look at the support and confidence for each rules, and then we will prune the rules or cut off some of the rules that fail to fulfill the minimum support and minimum confidence threshold. So for this is one of the example. So suppose that we have the same item set. The same item set is that we have the milk, and we have diaper, and we have beer. Okay, but from this item set we can form many rules. This is rules that we can use based on this three item set. So if you look at the support is always the same because we are looking at this item set, but the confidence is different because it depends on your item on your left hand side, which is the antecedent. Okay, so we can see that the rules for this one, the confidence is 1, so this is the highest rank. Okay. Okay, so there are two-step approach. The first one is to generate all item set who support the minimum support. So we want to eliminate the other item set that do not fulfill the requirement here, which is the support is greater than the minimum support threshold. Okay, so from there we can generate the rules, and then we only take the high confidence rules from each of the frequent item set. Okay, so these are the two steps that we have. This frequent item set generation is still computationally expensive because we need to scan all the data in your sparse data set. And then you have to do a combination of antecedent and consequent. So that's why they introduced this a priori algorithm. Okay. So if we look at, for example, if in the item set we have A, B, C, D, A, B, C, D, E. So this is 5 item set. So we will start with one item set first, like this. This is the first level, and then the second level. So we take all combination, and then we have the 3 item set, 4 item set, 5 item set. So we have so many candidates here. So that's why it highly depends on the number of item set that we have. So the possible number of candidates will be 2 to the power of D, which is D is the number of item in your data set, in your set. So in this case, 2 to the power of 5, we have 32. Okay, so based on this 32 number of candidates, so we have to determine which one is the frequent item set. Okay, so if we want to use brute force, so that means we will have this test for 32 number of computation. So how do we cut short this computation? Okay, so if you look at the number of possible candidates here is 32, but if we look at the number of computation here is that we have the list of candidates here, okay, the list of candidates, and we also have the number of item here, and we also have the number of transaction here. Okay, so the complexity of the computation is the multiplication of n, which is the number of transaction and number of item set, and also the number of list of candidate for the rules that we have. Okay, so for example, if 2 here, so the list of candidate is 4, and this is 16. Okay, so that means we have to add all this number of list of candidates that we have, and so on. So this is very expensive because we have this. Okay, so what can be done? So the best thing is we need to reduce the number of candidates. Okay, so how do we reduce the number of candidates here? We can use the minimum support. No. Somehow we need to look at the pruning technique to reduce the M. Okay, so we need to look at the frequent, because before we go into the support and also the confident, we can do the support count. The support count is just counting the frequency of the item set. Okay, so we can use pruning. We will look into this. We can also reduce the number of transactions, or we can reduce the number of comparison by using binary tree or other method that we can use in order to reduce the number of comparison. We will look also what we call it frequent tree, because as you know that if you arrange your data in binary tree or in a tree, you have n log n complexity. So this is proven already. So rather than we have them in a list of table. Okay. So in the a priori principle, they say that if an item is frequent, okay, if an item set is frequent, then all of its subset must be frequent. So for instance, if ABC is frequent, frequent means the number of occurrence for ABC is greater or equal to the minimum support, or the minimum frequent. Okay, minimum frequent. So then the A, B, BC, AC, ABC are all frequent because all of these are subset of ABC. So based on this assumption, they make this statement saying that for all X and Y, okay, for all X and Y, such that X is a subset of Y, we will have the support of X, which is always greater than or equal to the support of Y. Okay, so for example, if we have A, B going to C, so if this is frequent, so X is this one and Y is this one, the support of X is always greater than support of Y. Okay. No, this is not the X and Y, sorry. If we have A, B, C is frequent, and we have A, B is a subset of A, B, C, right? So the support of X, the support of AB is always greater than or equal to the support of ABC. Because then the number of items is getting smaller, right? So the support would be higher or equal to the support of ABC. Okay, we will look into this graph later on. Okay, so for instance, this one. So if we found that, okay, we can check each one of these. Like we start with one item set, and then we can eliminate which does not fulfill the frequent minimum frequent value. So for example, this is not frequent. So what happens is that the whole candidate below this will not be considered because this is not frequent already. So we don't have to evaluate all of this. Okay, because of the a priori condition. Okay, because we are saying that if if ABC is frequent, so AB is also frequent. Okay, and we are saying that the support of this is always greater than the support of this. So if this is not frequent, so this is no more frequent. So that's why we prune all of this. So this is one of the way on how we reduce the number of calculation. Okay, so we will look into the a priori algorithm. We start with this example. Okay, so for instance, we have this sparse database. Okay, so we will list all the one item set first. So this is one item set. And based on this one item set, we will count the number of times they exist in the sparse database. So basically, number of record containing individual item set that we have here. So bread, coke, beer, milk, and diaper, eggs. So we have 6 item set. No, 6 different one item set. Okay, so given that the minimum support is 3, so the counting which is less than 3 will consider to be not frequent. So we eliminate this one from the list. So the next one, we will go, okay, we combine this bread and milk, and then bread and beer, and then diaper, and then we continue with the rest. So these are all the possible candidates that we can generate from the one item set here. Okay, then again, we compute the number of appearance for these 2 item set. So this is 2 item set. So based on this, these 2 are less than the minimum support. Okay, so we eliminate that one. Then next is we will combine this with this, and then this with this, and so on. So, but for the 3 item set, we only have this, which is frequent. So from here we stop because no more combination that we can get. Okay, so this is the first part, which is identifying the frequent term for the K item set, which starting with 1, 2, and 3. So once we have this frequent item set, then we can generate the rules. So for this one, we have 2 to the power of 3 number of rules that we can generate. Okay. Okay, we give you another example here. So suppose that we have 4 transactions here. So we have all different number of items. So the first thing that we need to do is the first scan is to list all the one item set here, and then counting the number of record consisting this one item set. Okay, so the in here the minimum threshold is 2. So 1 is not frequent, so we eliminate this candidate. So we have only this. Okay, so now we can combine AB, AC, and then AE, BC, BE, and CE. So we have this. And then we scan again and compute the number of times that exist in the database. So we eliminate this AB and AE. So we left with this AC, BC, BE, and so on. So we combine this with this. So, okay, so we combine this and this and this. Okay, so for this one, when we combine these 2, we have A, B, C. But A, B, C, because A, B, C, when you combine these 2, we have A, B, C, right? But we know that this is not frequent. So this is also not frequent. So when you combine ACE, ACE, so this is not frequent. So AC is not also frequent. Then we have BCE. So BCE, we have 2. Okay, these 2 we cannot combine because this is 4 item set A, B, C, E. Okay, any question? Okay, so one of the question in the exam will be this one. So this is a very easy one. Okay, so this is based on a priori principle. So we start with one item set. So we look at the minimum support, then we will eliminate the one that does not fulfill the minimum support requirement. Okay. Okay, so this is a priori principle. We have another one, which is the frequent pattern tree. Remember just now, one of the way for us to reduce the number of calculation is to use efficient data structure. So if we use 3, the number of calculation or the number of comparison is n log n, where n is the number of items that we have. So which is reduce number of comparison. So that's why the one of the work that they have done is they look at this one. Frequent pattern tree. What is frequent pattern tree? Okay. So for this one, we use a compressed representation of the database using the frequent pattern tree. Once we have constructed this one, then we use this one to recursively divide and conquer approach to mine the frequent item set. So this is much the number of comparison is reduced. Okay, so given this item set, this item set, so first we start with a null. Okay, and then we go A, B, so we have A, B, so the number here tell you, okay, A and B occur one time in this, then we are here. Okay, so now we go to B, C, D, so we start from here again, but there is no B, so we will open another branch. So we will have B, C, E, B, C, D. And the one that connected the same here, so we will have a link. Okay. So we need to link this one because we know that, okay, this is 1, this is 1. So that means the number of B is already 2. Okay. Okay, next. A, C, D, E. So A, C, D, E. So A, C, D, E from here. So when we start from here, so we have A. So we will update this one to A2. But when we go down here, we don't have B, C. Then we open another branch, which is C. So occur one time. Okay, and then D. D one time. And then E one time. Okay, but this C must be connected to this C. And then D must be connected to this. Okay, so next one is ADE. So ADE, so we start from here. So A will be changed to 3. And then D, we don't have D, so we have to open another one, which is D here. And then this is 1. And then E, bawah. So after a few iterations, we will have something like this. Okay. So the number here refers to the number of appearance for A itself. Okay. But when we are here, you see 5. So that means the number of appearance of A and B. Because when we go here from the null going through A and B, so that means at this level, we have AB, the number of occurrence for AB is 5. Okay. And we also have this, don't forget about this. The link that we have here, the header table here. The link of B here connect to here. So this will be used to count the number of appearance of item set B, which is 8. So similar to E, we have this. So we only have 3 for the one item set E. Okay. So when we look at the application here, so for example here, if the minimum support is 1, so basically we have A, B, C, D, because minimum support is 1, right? Okay, so we have A, B, D, and then A, C, D, A, D, and then B, C, D. All of them are frequent item set. But if we change the support to 2, so if the support is 2, so we only have A, B, C, because when we are here, the A, B, C counting is 3, but the support is 2. So okay. So when the support is 2, we have A, B, C. We cannot have AC because C is 1. This one is also 1. So this is not frequent. Okay. So this is our frequent item set. And of course, based on the definition also, we have A is frequent, B is frequent, C is frequent, A, B is frequent, A, C is frequent, and A, B, C is frequent. No, B, C. We have A, B, A, C, and B, C. Okay. So that's how we use this frequent pattern tree in order to keep track the frequent term for the market basket analysis. Okay, so we look at some of the example that we have. So this is the data set that we have. In this example, we have this data set, sparse data set containing 9,835 transactions. So we have 327 transactions per day. Okay. And roughly 30 transactions per hour in 12-hour business day. So a lot of transaction here. So if the data set that we use is called grocery, so we have all this. So the content of this grocery is illustrated here. So where each row will have different number of item set. Okay. So if you have this kind of data set, so the best way to analyze them is using the a priori algorithm. So for the purpose of extracting rules. Okay. So based on the data set that we have, this is what we call the sparse matrix. So what we want to do is we want to count the number of appearance of each one of them. Okay, so the package that we need in order to deploy the a priori algorithm is arules, a priori rules. So we install this package. And then since we have a sparse database, so we will use this function called read transaction that will read the data that we have stored in here. Okay, so what we have in the data set, let me check if I can show you. Okay, can you see this? So this is a sparse data set. So each row will have different number of items. And we store this one as a comma separated vector. So comma is used to separate each item for each transaction that we have. Okay, so whenever you have this kind of data set, you can use a priori algorithm. Okay, so we use this statement in order to read our data. So this is our data, and we use this one as a symbol to separate each token that we have in the grocery. So we use this function. Okay, and we can do some summary saying, okay, transaction as item matrix in sparse format. So what we have here is that they can list all the possible, the most frequent item set, which is whole milk, 2,513, or other vegetables, 1,903, and so on. So this is the most frequent term. So only one item set. Okay. So we can use this summary also, for example, like this. So this is for one item set, we have number of transaction. And for 32 item set, we only have one number of need. Okay, so this one also can be extracted from our database. Okay, so we can use this command to inspect the content of each of the row. So for this one is for row number 1 up to 5. We inspect the content of the first 5 rows here. Okay, and we can also look at the frequency of this. This is the number of the row index. This is the column index. So over here we are looking at the items stored in column 1 to 3. So in this one we have this the abrasive cleaner, and then the second one is the artificial sweetener, and then this is the baby comestic. So this is stored in the column number 1, column number 2, and column number 3. So this is the item frequency. Okay. Okay. So they are sorted in column by alphabetical order. So A, and then A, and then B. Okay. Also use item frequency plot. So this one will plot your item in your grocery database. So this one will give you the item frequency for individual one. You can reduce the number of items by saying that I want only to display all the items that consist support at least 0.1. Okay, we can also see the number of top N, so top N of item in our data set. So this one will give you all the lists. We also have this image. So this image is basically looking at the area where you can see what are the common item that is bought in the transaction. So for here, this is the row. For this one, refer to the item that we have. So if we enlarge this one, become 100. So this is the transaction that we have, and this is the item that we have. So if we look at here, this is empty. Okay, so we can do something about this. We don't sell this one, or we can say that, okay, this is very popular here and also here. Okay, so we need to look at what are these items, or even this one. Okay. Okay, but this one just give you the visualization, but how do we extract the rules from here? Okay, so this is the command that we can use a priori. So what happens is that we will feed the data that we have, and then we can list the minimum support and also the minimum confidence that we have. And then all the rules will be extracted and stored in here. So we can export this one to Excel. Okay. So remember that we have so many rules that can be generated. So we can order them based on the leaf or the confidence or the support. Okay. Okay. In here, we are applying a priori algorithm for this data set. And this is the minimum support that we have. Minimum length refer to number of items that we have. Okay. And so based on this, we can check here the number of rules. So you see, even if we set this one with a certain value, we still have 463 rules. So to prune more, so we will need to increase the support and also the confidence here. And from here, we can look at some of the rules that we have. So we can extract here. No, this one is we have left-hand side plus left-hand side plus right-hand side. So this is the size. So if we have 2, so that means 1, 1. We have this 1, 5, 0 rules. So if we have 3, so that means we have this is 2, 1 or 1, 2. So we have 293 and so on. Okay. Okay, so for the rules that we have, we will use the support, confident, and leaf. Okay. So if you look at the value that we have here, okay. So this is the first rule that we have. and then this is the highest one. So the leaf is 3.95. Okay, so they are arranged based on the leaf here. So these are some of the top 5 rules that we can get from the grocery rules. Okay, so by the leaf order. So we only display the 5 rows. We can also focus on certain item. For example, here we are looking at the rules here, but we just want to see berries. So we can extract these rules, and store them in the berry rules. So once we get that one, we can inspect the rules here. So based on the leaf order here, so we know, okay, this is some of the rules that we can extract based on the berry. Okay. So that's how we focus on certain item that we want to focus. Okay, to export that, very easy. So we just write these rules into this file, and we use the comma as the separator, and we we don't use the row names. Row names normally is the row ID 0, 1, 2, 3, and we say the rules are in the code, double quote. So, example here, yeah. Okay, so we have done some research on this. Let me show you some of the paper that we have. Okay. This is the work that we done for the whole Malaysia. We collect the data from the 13 states. So what we want to do is we want to look at the purchasing behavior of agri-food commodities. So this is fresh agro-food. Okay, and this is what we get. So we have beras tempatan is the most frequent. This agro-food is fresh agriculture food. Okay, so beras tempatan is the most frequent one, and then next followed by the ayam and so on. So this is the top end. This is we take the top 30 items in the basket of, which is the number of transactions that we have. Okay, so we use all this. So these are the rules that we have. So whenever we buy Ayam Super, so this is one of the grading, and then Kembong, we also buy Bawang Besar Merah. Okay, so based on this, these are some of the rules that we have. So the blue one, the combination of the blue one will produce the Bawang Merah lah. Okay, so this one also can be extracted. Okay, so we use the support, confident, and then the leaf here. So this is more complicated argument rules. So this one we can look at the relationship between rice commodity and other commodity. Okay, so this is the rice. And many more. We have another one. Okay, this one is based on states. So we pecahkan lagi our analysis into states. So we are using the same data set, but this is for Kelantan, Kuala Lumpur, and then many more. So each state will have different rules. So quite interesting because we have different rules for different states. So this is two of the paper that we have produced for analyzing the market basket analysis for the whole Malaysia. So for your information, the grant that we have from this is amounting up to 10 million. Okay, so any question?
No questions, doctor.